In this video, welcome to the first video on design of a rectangular footing. In this video, you will understand the problem statement and do the initial calculations so that you can proceed with the design in the software. This is the problem statement for design of the combined rectangular footing, having two columns. The dead load acting on the footing center, through the column axis, is 500 kilonewtons for each column, and the live load is 250 kilonewtons for each column. Both the columns are square columns, of size 500 mm by 500 mm. You'll have to use reinforcement bars of diameter 20 mm. The safe bearing capacity of the soil underneath is 200 kilonewtons per meter square. The materials to be used are concrete of grade M30, and reinforcement bars of grade HYST 415. Consider the allowable settlement of the footing to be 1 cm. Now let us do the initial calculations. The area of the footing to be designed is given by total load divided by the safe bearing capacity of the soil. There are two columns, so the loads on each column have to be multiplied by 2. Thus, total dead and live load will be given by 2 times 500 plus 2 times 250. And the SBC is 200 kilonewtons per meter square, as mentioned in the problem statement. So the minimum area required comes to 7.5 meters square. For the sake of simplicity in calculating the dimensions, let us take the area to be 8 meters square. As it is a rectangular footing, you have to divide the area into its length and breadth, conveniently. Assume the breadth as 2 meters. Since area is given by length multiplied by breadth, the length is area divided by breadth, which is 4 meters. Now you can understand why the area was rounded off to 8 meters square, instead of taking 7.5 meters square. Thus the footing, with two columns of dimensions 500 by 500 millimeters each, has a length of 4 meters, and a breadth of 2 meters. Thus, from the center of the column, the breadth can be divided into 1 meter each. To maintain uniformity, the distances of the column center from the left and right side edges can also be taken as 1 meter. The remaining length, after deducting 1 meter from both sides, will be 2 meters, which between two columns. The distances from the column centers to the footing edges, as entered in the software, will be: left edge distance is calculated from the center of the leftmost column, and so the value is 1 meter. Similarly, the right edge distance, as calculated from the center of the rightmost column, is 1 meter. The top and bottom edge distances will also be 1 meter each. Now you will calculate the subgrade modulus, which is a property of the soil. The subgrade modulus is given by the safe bearing capacity of the soil divided by the allowable settlement. The SBC is 200 kilonewtons per meter square, and the allowable settlement is 1 centimeter. 1 centimeter is 10 to the power minus 2 in meters. Thus, the resulting subgrade modulus is 2 into 10 to the power 4 kilonewtons per meter cube. Next you will calculate the design strip width. You will be drawing the column strip. As per the design codes, the width of the column strip, on either side of the column center line, is given by 0.25 L1 or L2, whichever is less. L1 and L2, being the footing slab dimensions in X and Y directions, are 4 meters and 2 meters respectively. Thus the strip width is given by 0.25 times of 2 meters, which is the lesser value, and it equals half a meter. So these were the primary calculations, based on which you will be designing the footing in the next videos. Thanks for watching.